Good afternoon, everybody. This is Michael Pink calling from, sitting here down in Georgia, ready to walk you through a webinar today. What we're looking at today is it's called Analysis and Interpret Schedules Like a Pro. I would definitely like to scale that back a little bit and say we're going to use a program to help us. I am a former scheduling consultant. I spent a lot of time doing these things, but I hate calling myself a pro in anything because there's always a lot to learn. But nonetheless, I'm going to walk you through today how to take schedules, how to understand them, walk you through a little bit of why this is important, and just use the program as well. One of the things that I've been asked by many of our customers is to show a live demonstration of me walking through a program, a schedule, or a project, and utilizing the program to understand it better. So today I'm going to actually do that as well on a live project and go through the steps that I go through now using SmartPM to better understand things like schedule quality, delay, mitigation, feasibility, looking at that at a schedule by schedule basis as well as on a holistic basis for a project. I am definitely open to anybody asking me any questions along the way. This is more of a casual webinar where people can ask me questions. We don't have to wait until the end. It's going to be generally walking through the program a little bit off the cuff, but nonetheless, hopefully it's educational for everybody on the line. The first thing I'm going to do is I'm going to add the project. I've got to go find the native schedules. We're just going to call this the demonstration project. Go find the XCRs. I've got to punch in my location because in this particular program we do track weather. But the first thing I'm going to do is establish the baseline for the program. So I've found the baseline. I found the first schedule on this project, which I'll talk to you a little bit about this project in a minute. But just to get started, I want to load the data because it takes a little bit of time. I believe it'll take about 10 minutes for the program to take the 16 schedules that I'm about to load and analyze it such that I can understand it. So right now we see that the baseline's been loaded. I want to add all the subsequent updates right here. You'll see that we have about 16 schedules. I'm going to load them in. The program's going to take a quick look, see that all these schedules are validated, that there's no problems with those schedules, and once they are all validated, I'm going to upload them into the program, at which point the program's going to kick off a number of analyses. And while this is going, I don't think we want to sit here and watch these load for the next 4 or 5 minutes. So what I'm going to do is I'm going to pop open again a PowerPoint such that we can talk a little bit about what's happening here in the background and what all that means. The project that we're looking at today is a live project that I've worked on in the past. It was a $28 million project. It was an 18 or so month project. We had 6+ months of delay, and we spent about 240 man hours or 6 weeks doing an initial assessment, looking at things like schedule quality, looking at the updates, understanding whether or not the schedules were feasible or if there was too much compression, taking all that into account to study delay. Once we did all that, we refined the analysis based on any data integrity issues that we've encountered, and ultimately we created a graphical representation of what we found. And that all took about 6 weeks of my time. Today we're going to do that in an hour, doing a analysis of the project that we're looking at today, which is relatively a small project. Still took 6 weeks of time to get to a place where the parties could agree to something when it relates to delays, causation, responsibility, and whatnot. And if you do the math, if you're charging $300 an hour for 240 man hours, you're looking at a close to $75,000 bill just to study delays. So we are now into the product. We are going to analyze this, and I'm going to walk you through my process of analyzing a live schedule. This is our program dashboard. This is what tells us the state of the project at the time of the most recent update. This most recent update being June 13, 2016, which is approximately 18 months later than the original baseline was submitted. At this point in time, we can see that the schedule quality has gotten pretty bad. It's an F. It's failed the smell test of what constitutes a good quality schedule for managing a job. So we need to understand that. We also see that the project should be done. It's not. It's at 89% when it should be at 100%. We see that there was 203 days of delay. We see that the end dates shifted out 170 days, meaning that there was 33 days of recovery. I want to study that a little bit, but most importantly, I need to understand what those delays were. Our feasibility metrics are starting to tell us that we're getting a little compressed, but nonetheless, it looks like we're far enough along in this job that we'll be wrapping it up by September 13th, whereas the current end date says September 2nd. All of this information is just a high-level look at the job at the time. What I'm going to now jump into is doing an analysis of the data from the beginning to the end. If I scroll down this page right here, you'll see that I have all my schedules laid out. Baseline, update 1, update 2, update 3, all the way through our update 16. I'm able to actually open these schedules up in this program. We have the ability, we have a CPM scheduling engine built in. We have the ability to open any schedule up. We have the ability to organize it. We have the ability to filter it. Something that's missing from a lot of places with people who are analyzing schedules or need to analyze schedule is a bit of the history and the ability to actually open up and interact with the schedule. This is actually built into our program in case you need it, if you need to summarize it or look at delays and whatnot. But right off the get-go, I want to look at some trends. I want to look at where did we start and where did we end up, and how did we progress over time. What this program's telling me right now is, starting with the baseline schedule, where we were supposed to be 2% complete, we started right off the bat at 8% complete, which is good. We're already ahead of schedule. However, in that next update, we see that we're at 16, we're supposed to be 16% done, but we're now only 13% done. And then this trend seems to continue over time, slowly separating from where we're supposed to be and where we're at. All the while, we're going to look at the number of activities that are in this plan just to see if there's any point in time where the schedule either increased or decreased in the amount of activities, because that's pretty relevant. I actually have a few other schedules I can show you if we have time, but this is generally a small schedule. We've analyzed projects that have 30, 40,000 activities, and what you usually see in some of these schedules is that they start somewhere with maybe 1,000 activities and they end somewhere else with about 30,000, and needing to understand how that got to so much detail over what period of time is important. But here I am looking at this project. I can see that it's slowly and drifting apart from where we're supposed to be and where we're at. I see that this particular period right here seems to be the point in time where it really drastically changed. Like we were supposed to be at 24%, we're at 19. We're supposed to be at 28%, we're at 19. We're supposed to be at 37%, we're at 30. Now we're supposed to be at 52% and we're at 34%. So in this period on age 26, as well as the next period 10-2, we see a lot of slowing down on this job, and we never actually see that speed up too drastically. As a matter of fact, if we keep going down the line, we can see that we went from 39 to 43, 43 to 51, 51 to 52. We're slowly creeping on this job where we're supposed to be drastically improving our progress in this period of time. This is that middle period of time where performance needs to be at its best, and it looks like we're seeing impacts and whatnot, and slowly progressing as compared to where we're supposed to be. So I want to dig into that a little bit as well, and I can do that using our analytical engine. One quick thing I'm going to do right now is make sure that I have seen everybody's questions. I'm taking just a quick break as I open this up. Somebody did ask a question. It says, hi there, in your perspective, is it necessary and realistic to resource load every project schedule? I'll answer this question real quickly. I don't think it's necessary. I think it's valuable. I would say 98% of the world doesn't do it, so it's not necessary. I've seen many people manage jobs very well using analytical techniques that don't include resource loaded schedules. So I don't think it's a necessity. But that all being said, I do think it's a best practice. I think understanding your resource requirements from a scheduling perspective and being able to look at that holistically on a project is important. Particularly because there's a lot of discussions in trailers that there's not enough resources at the job, and there's a lot of arguing that there is. But the reality is the certain amount of activities, if they're resource loaded, and if we're able to take a snapshot of resource requirements based on all the activities that are going on using a tool like a CPM scheduling tool, then it's very telling. It'll tell you, can you get enough resources or not? Do you need 100 and you only have 50? That's very telling stuff. But if you don't have a resource loaded schedule, you don't really have that visibility at all times. But thank you for the question. As I move on to this project, as we can see, we got our 16 schedules loaded. I want to look at all these metrics as we go across. I want to be able to see, how is our quality trending? How is our delay trending? How is our recovery trending? How is our compression trending? From a high level, just to see if there's anything else that I need to take mental note of as I go through this process of studying schedules, in this case forensically, to better understand delays. But as you can see, starting with the first schedule, received a C grade. A C grade, as we all know, is about average, not terrible, but not great. So we want to dig into a little bit on why was the schedule quality affected on the baseline, because if we believe that the schedule quality is an indicator of a poorly constructed schedule, then we need to start to think through any sort of additional modifications or modeling efforts that we need to take to make this analysis more accurate or understandable or believable. Because if you have a schedule that's of poor quality and just generally not reflective of accuracy of the job in the beginning, not highlighting the true critical paths or whatnot, then you have a problem. And just a perfect example of that, and I don't think that this is the case here, but I see this all the time, particularly in high-rise buildings where people forget to put in crew logic. Generally they'll put in logic from one floor to the next in concrete or structural trades, maybe put some logic in amongst the MEPs, but generally not put any logic in the schedule for things like drywall or carpeting or millwork, basically telling the schedule that there is no crew restraint. And when that happens, we generally see a critical path that moves up the structure and then resides on the top floor of the building, which we all know isn't generally the critical path of the job. The critical path is through the trades, through the center of the building, unless there's some sort of enclosure delay going on. But nonetheless, that's why we want to look at quality. We want to look at it systematically. We see here that the C grade, we started out with a C grade. It got better, went to a C plus, got to a B minus, which now we're starting to see a schedule that we believe is well constructed, but then again, it starts to degrade. We see it getting worse and worse and worse and worse and getting into the D grades down at the end, and ultimately an F, which is telling me something. This is telling me that things are changing and getting worse, that logic's going missing or bad practices are being followed. All the while, we can see delay increasing over time. I can see that we started out with a 9 days of critical path delay, then 29, then 35, then 44. Then we hovered around 44 and went eventually to 62 days, and then all the way up to 171 days of delay. All the while, I want to be able to look at how far is the end date shifting while this is happening. Generally, critical path, the definition of critical path method scheduling is that anything delayed is an equal delay to the end date of the job if it's sitting on the critical path. So if there was 44 days of critical path delay, we should expect 44 days of critical path delay to the end date, unless, of course, there's changes being made to the schedule. Generally speaking, if the critical path delay equals the end date variance currently, then there's not any changes being made or very minimal changes being made, and everybody who's involved in the project have accepted the delays for what they are and not come up with any plans to overcome them, which in some cases is a good practice, and in some cases it's not a very accepted practice because it ultimately says we're going to take longer and cost more money. But what you can see here is that, generally speaking, we're hovering around the same amount of delay days to end date variance up until this point in time. The same point in time, around 8/26, 10/2 to 10/26, where we see this schedule grade getting worse, is the same time frame that we saw the progress getting worse. And we also see that the end date's not changing and the compression's going up. So now I'm starting to understand something here through this trend. I can see that, we started out in okay fashion. Things got a little delayed, which is normal. End dates kind of mirrored that, but eventually there was a hard push to keep the end date, and compression started increasing drastically over time to a certain point in time. What I've seen in my career is generally people are overly optimistic. They want to keep the end date. Eventually, there's a point in time where the rubber hits the road and everybody knows that there's no way that that end date's going to be kept, and then all of a sudden it starts blowing out and the schedule gets to a level of compression that it should be. What you can see right here in this example, we're seeing changes happening, keeping compression going up, but then all of a sudden in this one point in time, the end date just blows out about 40 days, close to 40 days, whereas the delay didn't even reach that much. Looks like there's about 21 days of additional delay and about a 40-day kick out at that point in time. So now I start to understand that, delays are happening, schedules are getting overly compressed, potentially unrealistic, so I need to take that into account as I model. But really at this point, I'm still only getting a lay of the land on this project. I'm going to move on to quality because that's the first step. I see this C grade. I see that this is getting worse over time. I want to start to understand, why did I get this C grade, and is there anything even in the baseline that needs to be repaired? And then I want to start looking at other decisions that were being made over time to create modeling efforts that will enable me to ensure that I trust the data for what it is. So I'll go take a quick look at quality and I'll show you a few examples. We have the ability now to look at various different things that will educate us as to why did we get a specific grade. I'm going to go back to that baseline where we got that C grade, and I want to understand it. The things that we're looking for, or generally are looked for in these types of analyses when gauging quality, is what kind of logic is there. Most of the time people believe that most schedules should be filled with finish to start ties as opposed to start to start or finish to finish ties. That's at least what the DCMA methodology tells us. DCMA stands for Defense Contractors Management Association. They have written a paper which most of the industry has embraced on 14 or 15 points that we need to be looking at and assessing to gauge overall quality of a schedule. Types of logic, whether or not there's missing logic. Missing logic is basically saying that an activity does not have a predecessor and or a successor. The rules, best practices say in scheduling that every activity needs to have at least one predecessor or one successor, except for two activities: the start milestone and the completion milestone, because there's nothing happening before them. Things like negative lag is an indicator of too much compression or maybe too many start to start or finish to finish ties. High duration activities is considered a risk. In this program, it is customizable. You can choose what a high duration activity is and what sort of frequency would result in an impact to a grade. But for purposes of our default, a high duration activity in line with the DCMA methodology says about 2 months long is that threshold. I personally believe it should be less than a month every activity, but nonetheless, DCMA says 2 months. We track 2 months. This tells me that this particular schedule has 12 activities that have high duration, so I might want to look into that. And I can actually do that by clicking right here on this filter and just making sure that I believe that the activities that are high duration listed in here are the type that would not cause a problem. And the problems that high duration activities actually cause are when they become critical. They are very hard to status. They become critical very easily because, say 80, 100-day activity is potentially going to consume a lot of float, and it's that easy for something to consume enough float such that the entire critical path shifts. And an example of what happened, like why is that a bad thing? Well, it's not always a bad thing, but right here we'll see that elevator procurement is on the critical path. This is it's not on the critical path currently, but it is a 50 or 90-day duration activity. So if elevator procurement is delayed or doesn't start on time and all its follow-on activities don't start because we've got this 90-day fabrication threshold that could probably be 40 days if we really wanted it to be, we want to make sure that those aren't hijacking the critical path. But in this case, I don't see too many issues. Usually when you see a lot of procurement on long duration activity, that's okay because procurement periods are long. But that all being said, I have seen many a project where a procurement activity hijacked the critical path for something like millwork when the building wasn't even out of the ground yet, and people argued that millwork was delaying the job, and that's just not what happened. They're not even out of the ground yet. So we need to be able to look at that. We need to be able to assess that. We need to be able to maybe even model that if need be. Back to our quality grade here. Again, we also see things like high float activities. This thing is telling me that 33% of my schedule has over 2 months of float. So basically a third of my schedule can be delayed for 2 months without impacting the end date of a job. Now this could be true. It's a little bit of a red flag in my opinion, and it's also an indicator that there's crew logic potentially missing, which I might want to look into closer. In addition, there's other things like, are there a lot of constraints? Looking at the total relationships to activities ratio, making sure that that's not too low is important. If you think about construction, we want to have close to 2 successors for every activity, particularly in one that's complex, that's partially vertical, partially horizontal. That tells us that every activity has a place for the trade to go and something following them in suit. And that would definitely tell us that we would have a efficient plan. But when logic's missing and there's not enough of that telling us where somebody to go and who's supposed to follow, then we have an incomplete schedule, which again can cause errors in the analysis. So schedule quality is something that's very important. I think that this program that we've created makes it very simple. Again, it is something that you can customize. For example, if somebody doesn't care about start to start or finish to finish ties or the frequency thereof, then you can say in the program, don't ding my score for having up to 100% of my activities start to start or finish to finish. So this is how this program's versatile, because we do know that every organization out there has their own opinions of things. We're not out to help people or tell people how to do their job. We're out to help people understand their data the way that they want to understand their data. The next question here is about delay. We see some quality issues that we might want to address after we look at the delay information. But I can go right into a delay table right here, and I can start to get a lay of the land and understanding, how much delay was happening in the period. Were they mitigating any of that delay? What were the delays? And at the end of each period, did they make any changes? If we recall in this summary, we saw the grades getting worse. We saw the delay happening. We saw the end date changing for a little bit and then remaining stagnant and then all of a sudden blowing out again on 222. So I want to understand this in a little bit more depth, and I can do that right here with the delay table. The most important thing that we want to understand is what was driving the job, what were the delays, what were the critical path delays. One thing that I know that a lot of programs don't understand, a lot of the softwares out there don't contemplate, is critical path delay. I've seen a lot of technologies out there claim that they do delay analysis, but I don't think they do, because there's a giant industry of consultants doing delay analysis, not using tools like SmartPM, using manual paper and pencil math like I used to do. There are a couple tools that will help you understand delay variances, but really what we're trying to understand here is true critical path delay. What is driving the end date? Because when it comes to discussions about delay, that is what matters. At what point in time did the end date kick out, and why did it happen? What were the activities that were directly tied to that? And again, that does require that all necessary logic is in the schedule, which again always ties back to quality. But given the data that's in this data set, where we see various metrics of quality getting worse, we have to assume that this was the accurate data before we even get into modeling. So we're going to go look at the delay table. We're going to understand, at each period of time, how far did the end date shift out? How much delay happened? How much recovery happened? That's a little bit different than most other systems I've seen, or most other processes that I've actually been able to do because I didn't have time. But we're tracking not only what was the critical path delay, but was there any out of sequence work performed that recovered any of the delays that ensued historically? And how does that net out, for the end date of the job? So in this particular period, we see that the end date moved out eight days. The baseline said it was going to get done on 3/16. The update said it was going to get done on 3/24. That's 8 days. We see that there was 27 days of delay and 18 days of recovery. So we know that something was delayed day for day for the entire period potentially, or close to it. And all of a sudden they did something out of sequence. Something had to happen anyway. And this is proof that the person who was managing the project, managing the schedule, saw the delay for what it was and did some out of sequence work to stay ahead. And we want to know about that. What we see here is that there was a 9-day total delay, 8-day kick out of end date. That's generally close to each other, meaning that there weren't too many changes that altered the future of the job or are questionable. But we do want to know, of the 27 days of delay, what were they? It looks like the NTP was issued late. It looks like they had to relocate a mural. It looks like they had to do a little demolition as well as a site survey, but it appears to me that they started demolition and site survey a little bit early. That's how they got their 18 days back before they probably removed this mural. Which is important to note, and actually can be seen much, much closer, and I'll show you that in a second. I just want to walk through another period just so we all understand what is this data telling us. In this one other period right here, we see that now they're in the building. There's some delays happening to the shear walls and the wall framing. We see that in this period of time, we're now 43 days late from an end date perspective. From the previous period, we've lost 10 days according to the actual schedules, meaning the end date moved 10 days from 4/18 to 4/28. We see that there was actually 28 days of delay in that period. 28 days of delay, meaning had we not made any changes to the schedule at all, that update, the end date would have kicked out 28 days, but it's only kicked out 10. And this is the period of time where they started to really compress things, if you guys recall. If we go back to this summary, we see right here that the point in time where compression started to increase was the point in time where end dates didn't change. And that's actually an example of that right here. I'm sorry, I'm losing my place. That example is right here where we've gone from a 28-day delay to a 10-day end date variance, meaning that there's been some changes to the schedule. We need to make sure that those changes are reasonable. We need to make sure that those changes reflect a well thought out plan. AKA, we need to make sure that that isn't just somebody shortening durations and removing logic of critical or near critical activities to keep an end date, which I believe is the data is telling me that that's what was happening. But now the real question is what was changed, and that's where we can look at the changes. Each update has a change history. Each update has a number of changes made, and we can see that reflected in the previous trends, but now we can actually see how many changes were made and what kinds of changes were made. We want to track changes that affected the critical path, changes that affected the near critical paths. These are the changes that would happen first. If you think about somebody scheduling a job, the first thing that they do is they status the job. They take last month's update, they put in actuals for today, and they hit schedule and they see what happens. And if the end date kicks out, well, now we've got to start making changes to the schedule. And the real question is, what's the first bunch of changes that they made to bring that end date back in? And that would be on the critical path. And the next question is, what's the near critical changes? Because once you get through the critical changes, there could be some near critical paths that are pushed out too far, and those would be the next ones. So that's what we want to track first. SmartPM is going to easily enable us to do that. As you can see right here, we see very few critical path changes up until that point in time where we talked about where the compression started to increase. And now I want to understand the extent of those changes because I want to question them. I want to make sure that those changes aren't overly aggressive, aren't manipulative, aren't overly optimistic, aren't not thought through. Because what happens when they aren't thought through is more problems. Trades trip over each other. People start making plans for project delivery on time or in accordance with the schedule, whereas there's no way it could possibly happen if you actually studied the data, yet they've already planned for it and put controls in place to turn over at a certain point in time. In some cases, if we're thinking multifamily, they may already have teams of people coming to lease out space or people who have already purchased the property or have signed leases, you know, for a specific date. All of that comes with additional damages that if we don't have certainty on the end date at any given point in time, we run into a problem. So it's very important to be looking at all these things in tandem. Always looking at the quality grade, delay, recovery, and compression and feasibility going forward. So that's what we're trying to get a lay of the land here now is what are some of these changes? We looked at this 10.2 update. We saw that in that 10.2 update, we have 32 days of delay, 28 days net delay, 10-day end date duration. So we've gotten 18 days back, and I want to understand that. I want to go look at that schedule. I want to understand on 10.2 what were the changes that were made that altered the critical path. We can see that, I'm going to exit out of that real quick. We can see that of all the changes, there was 84 changes in this period, 46 of them hovered around the critical path, which is important to note. Now it's interesting to go see, well, what are those changes and how do they affect the job? I'm always looking for changes in duration. You know, that's the first culprit. We'll see that, you know, we've got some shortening of duration on a critical activity from 8 to 5 days in the ceilings. Do we think that that's going to happen, or is that something that would generally result in just an erroneous change? The other thing that we want to look at is deleted logic. We want to see where they were deleting logic. Right here, we can see that they were deleting logic between the installation of drywall and the installation of HVAC mains. Now, that's something that you might want to question is, are they really doing that work in tandem now? Are those the two things that are happening? They did it again here on the first floor. So we want to make sure that that's possible. We want to make sure that that's one of those things that is now unreliant, that they are maybe delayed, but they do have a mitigation strategy to start drywall a little bit early. Just a couple examples here. Again, we also want to see, always looking for changes in lags. This one went from -20 to 0, and durations as well. This one went from 2 to 3, so that's actually pushing it back a little bit. All things that you always need to be looking at. In this case, it was a little bit more complex, but you can see here that a lot of the changes that they were making in that specific period where things were getting compressed were hovering around the critical path, and now we have a list of what those changes were. And again, we see more data that supports the idea that things were generally being managed fine up until a point, and then we got over compressed, and then compression happened, decompression started to ensue. So you can see during this whole period, for the remainder of the job, the scheduler was constantly changing things around the critical and near critical paths, which again is a large red flag. Being able to actually pop them up, understand them, question them, and maybe even reject those changes for analysis purposes is what we need to be able to do at this point. And that's really where we're at, is now taking that analysis, taking a quick look at it. I'm going to actually open it up in delay analysis mode, where I'm looking at the schedule. I'm going to go look at the historical critical path. I've seen that there was a period of time, there were some quality issues that we may need to address. I see that there was some change issues and some overcompression issues that we see when it happened that we might want to incorporate into a future analysis here. But before I get there, I want to analyze the historical critical path in tandem with my delay table to make sure that visually it makes sense. You know, a lot of times people live the job, things should make sense as to what was delaying the job, and quite often, at least from my experience, people's opinions of delays without studying it are way different than what the data says. So it's important to understand what the data says if we're going to actually understand things like delay. But what you can see here now is a summary version of our schedule. I've rolled it up completely. This is something that I can, again, open up at the activity level and see our historical critical path at different points in time. This is one thing that SmartPM does differently than any other program, is it highlights the historical critical path. The historical critical path is a very important thing to know. It's a very highly argued thing as well. But the fact of the matter is, studying delay and looking at things week for week, day for day, is what's necessary to understand the historical critical path. It's just a very time-consuming effort. So what we've built is the ability to update a schedule every single day. So we take these 16 updates, we create a daily schedule update based on the progress data that was input, based on the changes to the logic over time, and we produce this historical critical path. And then that's going to tell me a little bit about this job. And I, you know, me being a person who's studied or been a part of construction can have a gut intuition as to whether or not this data is telling me something that I believe is accurate or not. But really what we see is that, you know, the first part of the critical path was through site prep, which is typical. We all know that when you're coming out of the ground, there's really nothing that can delay a job too much unless you have a bunch of procurement activities that are significantly delayed. But normally it comes through the site work, and then it gets into the structure, which we see right here as well. We see that the foundations and the slab on grade is really the next critical path, and then it moves into submittals. And that's where I have a problem, because normally it moves into superstructure. So I want to understand this. Why did the critical path go from foundation and slab on grade, which it should have, you know, it couldn't be anywhere else really, back into submittals? And then after that, back into superstructure. So I see a potential red flag here that I want to address. I'm going to actually open this up. I'm going to go look at the activity. I see that it was elevator procurement. Again, that was a long activity, an activity that had too many days, 90 days. I want to go look at a little bit on that activity to see if there were any changes made that I might want to incorporate into my analysis at an earlier point in time. So I can actually go look at this and see that on 8/26, that day, that 8/26 date, that everything got compressed, we see that they compressed elevators as well. The elevator procurement went from 93 to 30 days, which took it off the critical path. If you look at that 8/26 date, you know, we're in June, July, or no, I'm sorry, July, August, 8/26, that's the day that this came off the critical path. So that tells me that the person scheduling at the time made this change because it was a critical activity, and they didn't want it to be a critical activity, so they changed the duration to a 30-day duration, which I have a decision to make. Do I want to make that 30-day duration incorporated into the baseline now, just to see if that elevator procurement activity was ever, you know, would have been delayed had they had a reasonable duration in the baseline or not? But I have that ability with our program. So I'm going to keep, you know, digging through this. I'm going to keep looking at the, you know, the future critical path, just to make sure that there's not any other odd things. But I do see another odd thing. We've gone from site to foundations to submittals and now into superstructure, but then back into foundations before we got into exteriors. So there's another thing that I want to look at, and I can. I'm not going to do this right now because I think we only have about 7 more minutes. But I do want to show you something that once I go through this process, I've now taken a look at this data. I've now seen that, you know, I've got some issues that I want to overcome. You know, I think that maybe the schedule got too compressed at some point. So I might want to eliminate any schedule after a certain point in time, because once you get in a compressed state, the schedule is very unreliable. I've also noticed that there was a critical path delay that was immediately removed via a change. So I might want to create a scenario that eliminates some of the schedules, and it also shortens that one duration on that critical activity. So what I'm going to do now is go into create some rules here. I'm going to go make some changes. I'm going to go reject some logical changes, or actually, no, I'm going to revert it. I'm going to take that elevator change on that update, which was on, I believe, 8/26. I'm going to go find it. I'm going to go see right here that we have, I'm going to search for elevator. And I see that I do not, oh, it was a near critical change too. So I see this elevator procurement activity. I want to revert that to a previous period. I'm actually going to revert that to the baseline. I'm going to say that this is what I want that activity to look like, starting with the baseline schedule, because they changed it at some point. Clearly that duration was too long. I'm going to call it the elevator revert, and then I'm going to actually go analyze it with that in mind. So now I've got this rule that says elevator revert. I also want to maybe eliminate some of the schedules that I thought were overly compressed. By creating a scenario, I can go select all my schedules. Where are my schedules? I create an update. And there's all my schedules. All my schedules are listed here. I think that 8/26 date, that 10/2 date, we might say was becoming a little bit compressed. So we're just going to analyze those schedules leading up into that point of time where compression got too high. I'm going to skip all follow-on schedules, and I just want to take the as-built data using that 10/2 update. So what this is going to do is it's going to analyze based on, progression that was in tandem with what we believe to be accurate up until the point where it was too compressed. Then we're not going to rely on any of those schedules after. We're not going to rely on the critical path. The last schedule that in logic thereof that we're going to rely on is that 10/2 date. But we're going to analyze that as-built data all the way to the end of the job using that 10/2 data. So what we're able to do now is select which schedules we want to utilize, and when we see a schedule or a series of schedules that had too many changes that we disagree with, we can eliminate them from the analysis. The other thing that I can do is decide whether or not I want to analyze the full schedule or a portion of the schedule. This is really cool to me because I'm able to actually analyze to a specific activity, whether it's a subcontractor's completion activity or a substantial completion activity, a phase 1 milestone, dry-in milestone, or just any activity in general. We have the ability to select that and analyze specifically to that activity, because if you think about subcontractors being delayed, well, they have a different story than the overall story of the job in a lot of cases, and understanding that story and understanding how compressed they're getting is important. But for purposes of right now, I'm going to analyze the full schedule. I want to incorporate that elevator revert activity. So again, I'm only looking at the first 6 updates and the final one, because I don't believe that all those updates 7 through 15 were actually feasible. And I also want to incorporate that one change because I see the critical path jumping somewhere that just didn't make sense or was potentially erroneous, and that was actually supported by the fact that the scheduler shortened the duration at the time. So what we're going to end up doing is basically act as though that change was made in the baseline. We're going to analyze it again. So now we've got this scenario that's going to occur that actually analyzes that data the way that we would like it to be analyzed. And that's really, I don't know if we have much more time here to actually see the outcome. I can actually, what I'll do is I will print out the outcome. We have this reporting ability where we can print out our final delay analysis. I will actually print that out for you and send it to you for the most recent update so that you can have a copy of what that looks like. But we have this report that actually will show you everything that we were just talking about, the reasons why the schedule received a low quality grade, a digital version of a summarized version of the schedule, which again, this takes time to do manually. We have now automated that so that you can see your project, you can see your delays, you can see your historical critical path and all the updates for every period leading up until now. And this is really useful in identifying what's actually delaying the job. We have a delay table behind it that you can read through and understand and really discuss true delays. And then we also always have the ability to see what critical changes were happening as of the most recent update. I'll send that to you for our scenarios so you can see what the difference is. But that's basically all the time I have today, guys. I do have one question here. Is SmartPM cloud-based or is it utilized on a local machine or database? If both exist, are there advantages? No, we are all cloud-based. There is no way a computer that sits on anybody's desks could do any amount of analyses that we do with this program. You know, sometimes in some of these delay analyses, we're doing millions of calculations. And if we want it to get done in 7 to 10 minutes, it absolutely has to be on the cloud, especially if we're doing things like modeling and scenarios and whatnot. Good question and thank you. Are there any other questions here today? One thing that I do want to follow up with is if there are any questions about our tool, and if you would like to learn more, please don't hesitate to reach out directly. I'm going to actually show you our email is info@smartpmtech.com, or you can email me specifically. I am mpink@smartpmtech.com. If you would like to learn more about our program, that would be great. We'd love to show you a little bit about our program. And actually, I haven't told anybody here in my company about this, and I'm sure the salespeople will be very happy, but anybody on this call today who's interested in purchasing SmartPM on a project or a series of projects, I'm going to tell you right now, I'll give you 25% discount if you end up purchasing it before the end of the year. So let me know. That will be our year-end fire sale. But nonetheless, I am going to sign off. Oh, I have more questions. How do we upload baseline schedule to your software? Oh, you have to basically purchase a login and or utilize the freemium version of our program. But please reach out if you're interested in checking it out. And again, I will honor a 25% discount to anybody who was on this call who's interested in trying this out if they purchase before the end of the year. Please let whoever you talk to know that you were on the webinar, and I will make sure that they know to give you a 25% discount. Anyway, I think that we're out of time, and I don't want to take up too much of everybody's time. I know how the industry is. Everybody's more busy than they need to be. We all work way too hard, but hopefully SmartPM can shave off a little bit of time to your day if this is the kind of stuff that you want to be doing as part of your job. But again, thank you very much for the time. I really appreciate it, and I hope you guys have a great day, a great week, and happy holidays.